Hello, I'll be explaining my senior engineering project, and it's called a pitch grip teacher. It's basically a baseball that just teaches young kids how to throw certain pitches and how to grip certain pitches to prevent injuries. So a major factor in Little League Baseball is elbow pain, and that's because young kids don't properly know how to throw and grip baseballs. So my invention is to properly teach young kids how to throw a variety of pitches in baseball. To protect their elbows from getting hurt. As you can see on the screen, these are just some of the websites that display this, that elbow injuries because of improper mechanics. I went through when I was building, before I started building, to make sure this idea had already not been taken, and I discovered that there were some products similar but not quite the same. And so I decided that using a 3D printed baseball and LED lights would be the best because it would be durable and it would allow me to make a wide variety of code for plenty of different pitches that kids need to learn how to throw properly. So I use concepts such as coding and electricity. I coded in Microsoft MakeCode, which coded JavaScript for me. And so this picture you see on the screen here is just JavaScript. There were some design parameters though. This ball is not designed to throw at all. Here's some of my sketches of my original ball, my original idea. And then here are my drawing files in depth and completed. This is my completed baseball you see here in a drawing file, and it's 3D printed. These were my original laces before I had to modify because they didn't work that well. Here are my new laces, as you can see on the ball right now. They're hot glued down. These were my materials. This was my how to divide my work properly. Safety hazards. When you're soldering, if you decide you want to make something similar or just soldering in general, make sure to keep your hands away from the soldering iron as much as possible because it will burn you. Fumes as well, they're dangerous fumes, so make sure you're not breathing in those fumes from the soldering, and then always wear eye protection. This is kind of on the screen is my procedure of how I built it. I just 3D printed, catted my laces on my ball. I glued magnets on each side, as you can see here, so the ball could stick and stay until you put enough pressure to open it. An adhesive Velcro strip kind of as a hinge. And then I left about a 1-inch gap between two sets of 12 in soldering to allow for that hinge to work without lights getting in the way. And you can see here, these are my 3D printed halves. This is the process of soldering my LED lights together. And then you can see here's the Velcro hinge I was talking about. Here are the magnets. This is the Velcro down Circuit Playground Express I used from Adafruit. This is the closed ball, and then I attached this light strip to the ball. I bent it and then sprayed it down with a wire insulator so the wires wouldn't touch and short out. Then I glued it down to the laces gap so it would stay, and then I soldered the wires from the LED strip to my circuit board, and then ground was the blue wire, as you can see here is attached to the green alligator clips. V out was my gray wire, which was attached to the yellow alligator clips, and then my purple wire was my A1. These were my original laces. As you can see, they didn't work that well for molding around the ball, so I used my ball CAD in Autodesk Inventor to modify new laces that would fit better and mold around the ball. And then I used certain colors for different fingers to help kids learn how to throw it. So red's always forefinger, middle finger's blue, ring finger's green, pinky's yellow, thumb is purple. You want to remember that when I show you in a bit when it lights up for a few pitches. This was my test on my fastball pitch, which worked. You can't see the purple light, but it's down there for my thumb. And then this was just the simple code for the fastball, and make code on the left and JavaScript on the right. And so now I'll show you a little bit. So here's the LiPo battery. You can see right here it has a JST connector. It connects in here to this Circuit Playground Express. Once you put it in, it lights up, and I made it make a little noise just for some fun at the beginning. So this just shows it's on. Nothing special in code right here. It's just showing that all the lights work and that it's turned on. And so there's a bunch of different inputs on this circuit board. It's pretty cool. And right now I'm just using buttons A and buttons B. And button A, which is right here, codes a fastball. And so once I press that, you can see the fastball code here. And this is what's so convenient about the magnets. You can open and close it easily. Red is the forefinger, blue is the middle finger, and then the purple down here is the thumb. And it shows you your grip here of a fastball, which is pretty cool. And your other fingers rest on the plastic in the ball, not on the laces. So then the other pitch I have right now is a changeup, which is B, which is right here, button B. So once I press that, it'll change the code to a changeup. Same principles here. Red is forefinger, blue is middle finger, and as you can see, the blue goes, and green, which is ring finger, go down 2 laces, so your fingers are going to cover those entire ones. The red goes here for your forefinger, and then over here is your yellow for your pinky, and your thumb sits here, and then that's your changeup. And this is called the Pitch Grip Teacher, and it's just to teach young kids how to properly grip different types of pitches.